Hello, welcome to e-content for postgraduate classes. This class is designed for M.Sc semester 3rd final year students mathematics group. My today's paper is functional analysis and topic is normed linear space and examples. Myself, Dr. Shraddha Dubey, Professor, Department of Mathematics, Sarojini Naidu Government Girls PG Nutan College, Bhopal. After completing this module, students will be able to learn the definition of norm-linear space. They will be able to give examples of norm-linear space and would be able to state some properties of normed linear space. The preliminaries are, as we all know, विश्व का आरंभ एक पॉइंट से हुआ है, पॉइंट बिंदु, और अगर हम इन बहुत सारे पॉइंट्स को एक साथ मिला लें, उन्हें सुपरिभाषित कर दें, तो ये कलेक्शन बन जाता है, कलेक्शन ऑफ वेल डिफाइंड ऑब्जेक्ट्स दैट इज कॉल्ड सेट. जैसे जैसे एडवांसमेंट हुआ तो मैथमेटिकल ऑपरेशंस आए, और अगर हम नॉन एम्प्टी सेट के साथ एक एल्जेब्रिक स्ट्रक्चर बनाएं, अर्थात एक बाइनरी ऑपरेशन कंसीडर करें और वो 4 प्रॉपर्टीज सेटिस्फाई करें. ये 4 प्रॉपर्टीज हैं क्लोजर, associativity, existence of identity and existence of inverse. Then you all know it forms a group. Examples of group are I plus, where I is a set of integer, Q plus, where Q denotes the set of rational numbers, and R plus, where R is a set of real numbers. इसका और एडवांसमेंट हुआ और रिंग बनी. रिंग में 2 बाइनरी ऑपरेशंस शामिल हैं, एक नॉन एम्प्टी सेट along with 2 binary operation that is plus and dot, and it satisfies 9 properties. R1 R plus forms abelian group. इसमें कम्यूटेटिविटी प्रॉपर्टी इंक्लूडेड है. R डॉट सेमी ग्रुप अर्थात मल्टीप्लिकेशन के साथ ये क्लोजर प्रॉपर्टी और एसोसिएटिविटी को सैटिस्फाई कर रहा है. इसके साथ साथ लेफ्ट डिस्ट्रीब्यूटिव एंड राइट डिस्ट्रीब्यूटिव प्रॉपर्टीज भी सैटिस्फाई होती हैं. तो कुल मिलाकर 9 प्रॉपर्टीज यहाँ सैटिस्फाई हो रही हैं. एग्जाम्पल हम देखना चाहें तो Q प्लस डॉट, R plus dot and C plus dot, where C denotes the set of complex numbers. इसका और एडवांसमेंट हुआ एंड विथ जीरो डिवाइजर और विदाउट जीरो डिवाइजर का कॉन्सेप्ट हुआ बना, और उसके साथ साथ इंटीग्रल डोमेन बना. और अब जो लास्ट प्रॉपर्टीज में इंक्लूड की गई वो है एवरी नॉन जीरो एलिमेंट हैज इट्स मल्टीप्लिकेटिव इनवर्स एंड इट फॉर्म्स ए फील्ड. तो ये तो हुई ग्रुप, रिंग, इंटीग्रल डोमेन और फील्ड की बात. यदि किसी नॉन एम्प्टी सेट के साथ एक एक्सटर्नल और एक इंटरनल कंपोजिशन शामिल कर लिया जाए तो यहाँ पर वेक्टर स्पेस फॉर्म होती है along with few properties. तो let us see vector space. V and F are non-empty sets. Plus is the operation from V cross V to V. This is an internal composition. That is, if alpha and beta belongs to V, then alpha plus beta also belongs to V. And dot F cross V to V, it is an external composition. If F plus dot is a field, then the ordered triple V plus F plus dot along with dot is a vector space over the field F if it satisfies few conditions. Number 1 is V plus is an abelian group. You all know for abelian group, it is going to satisfy 5 properties. Secondly, V is closed with respect to multiplication, that is external composition. Third, if A of alpha plus beta is equal to A alpha plus A beta, where A is a scalar and alpha beta are vector. Second, A plus B alpha is A alpha plus B alpha. AB belongs to F and alpha belongs to B. Third is AB alpha is equal to A of B alpha. A and B are scalar and alpha is a vector. And lastly, 1 into alpha is equal to alpha. 1 is called unit element. Examples of vector spaces are RR, CC, and CR are vector spaces. Few more examples are set of all ordered n tuples and set of all polynomial also forms a vector space. चलिए अब हम देखते हैं नॉर्म्ड स्पेस और नॉर्म लीनियर स्पेस. देखिए ये दो शब्दों से मिलकर बनी है, नॉर्म्ड एंड लीनियर स्पेस. लीनियर स्पेस के बारे में हमने अभी जाना. नॉर्म कुछ प्रॉपर्टीज सेटिस्फाई करता है. तो नॉर्म लीनियर स्पेस इज ए लीनियर स्पेस n in which to each vector x there corresponds a real number denoted by norm of x and called the words में norm of x such a manner that number one, norm x is always greater than equals to 0, that is, it is always positive. And if norm of x is equal to 0, implies an implied x is equal to 0. Few mathematicians divide it into two properties. One, norm is also always positive, and secondly, if norm x is equal to 0, implies an implied x is equal to 0. The second property is norm of x plus y is less than or equal to norm x plus norm y. And third is norm of alpha x is equal to mod alpha norm x. कुछ प्रॉपर्टीज की तरफ दृष्टि डालें तो हम देखते हैं कि ये जो नॉन नेगेटिव रियल नंबर है, इट कैन बी थॉट एज द लेंथ ऑफ वेक्टर x. If we take alpha is equal to minus 1 in property third, then norm of minus x is always equal to norm of x. In particular, this property can also be written as norm of y minus x is equal to norm of x minus y. Next property, norm of 0 is equal to 0 if we consider alpha is equal to 0 in property third. Fourth property, norm of x is greater than equals to 0. Or if we take y is equal to minus x, then property 2 states that norm of x plus minus x, which can be written as norm of x less than or equal to, norm separate होता है तो less than or equal to की property यूज हो जाती है. ये वाला साइन यूज होगा नॉर्म ऑफ एक्स प्लस नॉर्म ऑफ माइनस एक्स. x plus minus x मिलकर 0. So norm 0 is less than equal to norm x plus norm minus x. Or 2 norm x is greater than equals to 0. Or we can say that norm x is always greater than equals to 0. Next property, mod of norm of x minus norm y is less than or equal to norm of x minus y. That is absolute value. देखिए एब्सोल्यूट वैल्यू कंसिडर की गई है. एब्सोल्यूट वैल्यू mod of x की वैल्यू होती है मैक्सिमम ऑफ x and minus x. So if we see the property third, we have norm of x is equal to y plus x minus y. नॉर्म सेपरेट करेंगे लेस देन इक्वल टू नॉर्म y प्लस नॉर्म ऑफ x माइनस y. y का अगर हम ट्रांसपोजिशन करें तो नॉर्म ऑफ x माइनस नॉर्म ऑफ y इज लेस देन इक्वल टू नॉर्म ऑफ x माइनस y. लेट अस कंसीडर इट एज inequality 1. Interchanging the role of x and y, we have norm of y minus norm of x is less than or equal to y minus x. This can be also written as norm of x minus y. Now by property 1, negative of minus of norm of x minus y is less than equal to norm of x minus norm y, which is less than or equal to norm of x minus y. So if we combine 1 and 2 as mod of x is equal to maximum of x and minus x, this gives us the required proposition. Next property is every normed linear space is a metric space. As you all know, for the metric space, we have to satisfy 4 properties. Now we have to define here a metric D in terms of norm, that is D of xy is equal to norm of x minus y. With this definition, we are going to establish that D satisfy all the axioms of a metric space. Firstly, dxy, which is equivalent to norm of x minus y. And as you know, norm is always positive, so this value is always greater than equals to 0. Secondly, d of xy, whose value is equal to norm of x minus y, which is equal to 0. If the distance is equal to 0, that means elements are same, so x is equal to y. Third is d of xy is equal to norm of x minus y, which can be written as norm of minus of y minus x. Along with property 3, it gives mod of minus 1 and norm of x minus y, and absolute value of minus 1 is 1. So this will become norm of y minus x, which is equal to d of y minus x. Fourth property of metric space, that is triangle inequality. So d of xy can be written as norm of x minus y. On adding and subtracting z, it can be written as x minus z plus z minus y. On separating the norm of x minus z plus norm of z minus y, which is d of xz and d of zy. Pictorial value can be seen here, x and y, and the resultant is given by x plus y. Same with norm. So in this way, it defines and satisfy all the four axioms of a metric space. So we can say that every norm linear space is a metric space. Further, we can consider norm as a continuous function. So if x1 d1 and x2 d2 are two metric spaces and f is a mapping from x1 to x2, then f is said to be continuous function if and only if xn tends to x implies fxn tends to f of x. That is, if xn tends to x, then its functional value f of xn also tends to f of x. Property first, norm is a continuous function. That is, if xn tends to x implies norm xn tending to norm x. Now, if we consider absolute value of norm of xn minus norm of x, then it is smaller than norm of xn minus x. And if it tends to 0, then norm of xn minus norm of x, absolute value tends to 0. Since xn tends to x implies xn minus x tends to 0. So norm value of xn minus x also tends to 0. That is, norm of xn tends to norm of x. So we have proved here if xn tending to x, then norm of xn also tends to norm of x, which states that norm is a continuous function. Second property can be stated as addition and scalar multiplication are jointly continuous. That is, if xn tends to x and yn tends to y, then xn plus yn tends to x plus y. For scalar multiplication, if alpha n tends to alpha, xn tends to x, then alpha n xn tends to alpha x. Let us prove first property. Then norm of xn plus yn minus x plus y can be written as norm of xn minus x plus yn minus y. On separating the norm, less than equal to norm of xn minus x plus norm of yn minus y. Here we have taken the help of axiom 2. Since xn tends to x implies xn minus x tends to 0, then norm of xn minus x tends to 0, and since yn tends to y, so yn minus y tends to 0. Our norm value of yn minus y tends to 0. Hence, norm of xn plus yn minus x plus y tends to 0. Xn plus yn minus x plus y tends to 0. So xn plus yn tends to x plus y. Now, scalar multiplication. Norm of alpha n xn minus alpha x can be written as norm of alpha n xn minus alpha n x plus alpha n x minus alpha x. Here we have added and subtracted alpha n x. On taking common alpha n, the next bracket we are getting xn minus x plus, here we have taken out x. So in this bracket we are having alpha n minus alpha. Property third gives less than equal to mod of alpha n, norm of alpha n minus x plus mod of alpha n minus alpha, norm of x. Since xn tends to x, this implies norm of xn minus x also tends to 0 and alpha n tends to alpha, so alpha n minus alpha tends to 0 implies mod of alpha n minus alpha tends to 0. On combining these two properties, we have norm of alpha n xn minus alpha x tends to 0, that is alpha n xn tends to alpha x. So we can say that scalar multiplication is jointly continuous. Now we have considered few examples of nonlinear space. Euclidean space Rn and unitary space Cn is one of the best example of nonlinear space. They satisfy all four properties to be the nonlinear space. Here we have defined norm x as summation I is equal to 1 to n mod xi I square whole raised to power half. This can also be written as under root of mod xi1 square plus mod xi2 square up to mod xi square. The second example is space LP. LP space. In the LP space, the norm is defined by norm of x is equal to summation I is equal to 1 to n mod xi I whole raised to power p, the whole raised to power 1 by p, that is pth root. Next, we can say that the space L infinity is also a norm-linear space where the norm is defined by norm of x is equal to supremum of mod xi j. And the space CAB where norm is defined by maximum of mod of xt and j is interval a to b is also one of the example of normed linear space. Now I am stating one more property, that is translation invariance. If a metric induced by a norm on a normed space X satisfies d of x plus a, y plus a is equal to d of xy, and d of alpha x alpha y is equal to mod alpha d of xy for all a, x and y belongs to x and alpha is scalar. देखिए यहाँ पर स्केलर क्वांटिटी को eliminate किया गया है. d of x plus a y plus a can be written as norm of x plus a minus y plus a, which is equal to norm of x minus y, which is the value of d of xy. And d of alpha x alpha y can be written as norm of alpha x minus alpha y. Alpha we can take alpha common, mod alpha d of xy. For further reading, students can refer Kresge, Introductory Functional Analysis, Chaudhary and Nanda, Functional Analysis, A. Taylor, Functional Analysis, B. Villemie, Functional Analysis, and B.K. Lahiri, Elements of Functional Analysis, Walter Rudin, Principles of Mathematical Analysis. इन सभी बुक में आपको प्रिलिमिनरी के साथ साथ नॉर्म लीनियर स्पेस और उसके एग्जाम्पल और प्रॉपर्टीज का भरपूर नॉलेज मिल सकता है. Now few questions. If x, y, z are any three vectors in a norm linear space and alpha is any scalar, then the value of x plus z, comma y plus z. This is an objective type question. Is it d of xz plus dyz? Is it d of x plus z minus y plus z, which is equal to d of x y? Or is it d of x plus z into y plus z? Or is it d of x plus z divided by y plus z? So as you know, every norm linear space is a metric space. So option B is the right answer. Next question is value of d of lambda x lambda y. Options are norm lambda dxy. Second option is norm lambda x, norm lambda y. Third option is mod lambda dxy. And the fourth option is mod lambda x, mod lambda y. As you know, scalar multiplication is there. Lambda is a scalar. So the option C is right. Mod lambda d of xy. So with this, I end today's class. Thank you very much for patient hearing.